Hello, students. Today we're going to talk about ways to prove that lines are parallel. There's actually 6 reasons that are allowed to be used in a geometry proof to justify that 2 lines are parallel. So if you're doing a math problem and you want to say, hey, look, these 2 lines are parallel, you will need one of these 6 reasons. 4 of them use the vocabulary words that we were talking about recently, which were the ones like this one and this one. These 2 angles are alternate interior, or corresponding, or alternate exterior, or same side interior. Here's how this works. So in the previous lesson, we had this idea that if you have parallel lines, let me put that little extra arrow on it, then the angles that are in the same position are the same. So we have, if the lines are parallel, then we're allowed to say that the angle in the bottom right down here matches up, is exactly the same size and shape as the angle in the bottom right here. These are called corresponding angles. And if these lines are parallel, these angles are congruent. They're the same amount. So if I know this one, I know this one. If I know this one, I know this one, because they're the same. What we do in this section is we flip it. Okay, we take the converse. So instead of if the line's being parallel, then we know the angles are congruent, we switch it. So now we're going to say if those corresponding angles are congruent, then we can say that the lines are parallel. So that's how this works. So if the corresponding angles are congruent, then the lines are parallel. Converse is where you switch the hypothesis and the conclusion. All right, let's look at the next one. So the next one said, if you have parallel lines, then, so if these are marked that they're parallel, then the alternate interior angles are congruent. So if you have a math problem that looks like this, and you know these are parallel, and you have 112 right here, okay, 112 degrees for that angle, you are allowed to say that this one is also 112, okay, because these are alternate interior angles. And from the previous lesson, it said that if the lines are parallel, then the alternate interior angles are congruent. This is a lot of vocabulary. I know that, and it's a little bit abstract. So if you're following along, great. Okay, so for this one also, you switch them, and the end of the statement, the conclusion of the statement is the lines are parallel. So if you have a picture that looks like this, then you are allowed to say that the lines are parallel. It's a little nuance here, but you can handle this. All right, here's another one. If you have parallel lines, pretending like those are parallel. Oh, look, they're parallel now. And there's a transversal going across them. In this situation, if I know this angle, I know this angle and this angle together, they're not the congruent, they're not the same, they add up to 180. Okay, they're definitely not congruent, they add up to 180. So if you have a situation where you have parallel lines, then these 2 interior, remember this is the interior on the same side of the transversal, those are supplementary, they add up to 180. Okay, so the same idea down here. If these 2 angles in the interior add up to 180, then the lines can be said to be parallel. All right, and the last one of the 4 that uses the vocabulary is that if transversal intersects 2 parallel lines, alternate exterior angles are congruent. That's true. If the lines are parallel, then these two are going to be congruent. And the converse is also true. So if these two are congruent, then that would force the lines to be parallel. I said there's 6. So here are the other 2 ways. You can also say, if I want to show that line A is parallel to line B, if I know that line A is parallel to line C and line B is parallel to line C, then I'm allowed to say that line A is parallel to line B. That's what these markings are. So if the A with the little red mark is parallel to C with the little red mark, and B with these 2 little blue marks is parallel to C with these 2 little blue marks, then you're allowed to say that A and B are parallel. Geometry is fun. All these little language things. Okay, and then this one says if 2 lines, A and B, are perpendicular to the same line. So line A is perpendicular to line C, and line B is perpendicular to line C. If that's the case, then you're allowed to say that lines A and B are parallel. All right, well, here's a marking. Do you see how there's no little arrows right here? That means technically these lines are not parallel. Okay, I could draw the same figure and I could exaggerate it. I could draw it like this. I could draw line L and line M, and with a transversal going across it. And I could put my 2x plus 2 right here. And I could put my 3x minus 63 down here. And these 2 angles are not the same. This angle is a lot smaller part of the circle than this angle. So I could draw it like this, or I could draw it like this. What this question is asking is, for what value of x what would make it have to be that L is parallel to M? Or could it just be like this, right? And then which theorem or postulate would justify my answer? So if this angle and this angle, are these all interior or exterior? The angles I just marked. Good, they're exterior. They're not in, this is the interior. Are they on the alternate sides of the transversal or same side of the transversal? Yeah, they're on alternate. One's on the top of the transversal, one's on the bottom of the transversal. Okay, if they are equal and congruent, then the lines would be parallel. This is how you use those statements that we were just talking about. So if they are congruent, I'm going to take away 2x on both sides. Then the lines would be parallel. And I'm going to add 63 on both sides. Then I get x is 65. Okay, if x is 65, then 2 times 65 plus 2 is the same as 3 times 65 minus 63. This is the number for x that would make these lines have to be parallel. Okay, what's the theorem we used? We used that if alternate interior angles are equal or congruent, then the lines are parallel. No, I drew it. Okay, so to finish this question, you would say if alternate exterior angles congruent, then lines are parallel. That's the easiest way to write parallel, is just the 2 L's in the middle of the word parallel. that they wrote it like that. That means parallel. Okay, this one, same idea, except I'm not going to set these equal to each other because this one is small and this one is big, right? This is an acute angle and an obtuse angle. So if I try to say they're equal, that wouldn't really make sense. So what do we do in this problem? We would do 2x plus 20 plus 6x plus 24 is going to add up to how much? They're same side and they're interior. They're supplementary. They add up to 180. Okay, so that's going to be 8x and 44. And I'm going to leave the algebra for you to do. That's the lesson for today. More vocabulary. You need to be good at this vocabulary. Keep practicing. Good luck. Do your homework. Bye. I'm still here.